Hi, today I'll be demonstrating Baffle's Real Queryable Encryption for Pgvector. This allows people who are developing Gen AI applications using retrieval augmented generation to secure their vector databases storing all that context data, ensuring that that data is not only secure but remain compliant. Now, for those who may not be familiar with retrieval augmented generation and how the vector database fits in it, I thought I'd just go over the different aspects of how it all fits together. And it'll also make it a little easier to understand the demonstration because I'll be doing many of these steps manually, whereas typically you would actually implement this all in code. Now, as you can see, the first step of actually retrieval augmented generation pipeline or application pipeline is you're going to have a lot of contextual data that you will essentially generate embeddings out of and load into your vector database. In this particular case, we're talking about Pgvector inside Postgres. So we're going to use a Postgres database, and the Pgvector extension is already installed. After you have the context data, which typically will be in the form of text chunks and its associated embeddings, whenever a user actually attempts to prompt or ask a question, what the Gen AI application will do is attempt to augment that prompt with context data that it retrieves from the vector database. And in order to find the most relevant information or context data, what it's going to do is it's going to perform a similarity search based on the embeddings. So essentially, it'll generate embeddings from the prompt, and then we'll actually use that to compare against embeddings that are already stored across all the different text chunks or context data. It's going to actually pull out the best set of contextual data to actually send with the prompt to the inference server and get a response. And that response, of course, will eventually make it back to the user, making it really useful. And the reason why you want to do this, in a lot of cases, what you'll find is that if you actually just use the inference server with the already pre-trained LLM, it may not actually give you a question that's appropriate to what you're looking for. So for a large enterprise that's actually trying to find find responses based on data from their customer database, for example, obviously the publicly pre-trained LLM with public data is not going to have any of that, right? So that's why you actually have to augment it. The difference between the general retrieval augmented generation sort of pipeline or architecture and the one that we have here today of demonstration is the addition of Baffle's Real Queryable Encryption. You'll see right there that we have actually a Baffle encryption proxy, and of course we also have, not visible here, a Baffle encryption extension. And what it allows us to do is encrypt the data as it's actually loaded into the Postgres database through the proxy, so that actually the data is never visible to any users of the proxy. And when actually the application performs a similarity search, the similarity search can be done on the encrypted data. And that's one of the great things about Real Queryable Encryption, is that it's able to operate on encrypted data in the database, making sure the database remains secure at all times. All right, with that said, let's go ahead and walk through the steps of the Gen AI pipeline. Here you'll see that I've got the SQL script that's needed to load our vector database. It's got some chunks of data, basically marketing profiles, and their associated embeddings. For those of you who are curious, this is actually using OpenAI, I think small. So it's going to be about 1,500 and I think 36 size array here. But you could, with Pgvector, you can store any size array that you need for your vector database. And what we're going to do is go ahead and load that in there. Oops. This is how you know this is a real demo. Let's go ahead and not highlight something and run it again. There we go. All right, so the entire data set got loaded. And just to show you that it is in fact encrypted, we're going to go ahead and go to our tab here with a direct connection to the database. This is going to simulate an admin or any user that actually has access to the database. Now, if you're actually going to try and query the data or try to exfiltrate it, or the embeddings themselves, what they're going to be met with is, well, binary information. But of course, it's not clear this is truly encrypted, so we're going to go ahead and check that in hex. And sure enough, you're going to see from the hexadecimal values that the chunk column, which is where I stored all the context data itself, or text chunks, is definitely not text. In fact, it's this encrypted value where we have our standard Baffle prefix. Likewise, the embeddings does not look like an array of floats. Instead, it is our again, encrypted value with a Baffle prefix. So for direct users or anybody who's trying to access the database, they're essentially restricted from being able to see these values, which may have contained sensitive data. Now, if you're an application and has the ability to access the data and the embeddings through the Baffle proxy, you will be able to actually see the actual data, and that's going to be simulated by this particular query. Sure enough, as you can see, the original marking profile that was stored in the chunk column is in fact available here, and the embeddings you can see in fact is an array of float. Just to double check here, you can actually see, even though the display didn't show the full set, you can see here's the marking profile here. So anyway, this is actually the thing that Baffle can do, which is make sure that the data is encrypted transparently to the application, but in fact stored in the database in encrypted form. Now, having the data being encrypted form is all well and good, but what's particularly interesting for a retrieval-augmented generation application is that it needs to be able to extract the appropriate chunks based on a similarity search against the prompt, right? It's going to, someone asks a question, you want to find the most relevant context to serve with the actual question so they can get the right answer. And so to do that, what we're going to have to do, if you recall, is actually calculate the embeddings for a given prompt in order to perform a similarity search. Usually that would be a little bit tricky. So what I tried to do was to help myself by writing this I wrote myself a little Python script that'll take care of that. I call it get embeddings, and I've already pre-populated a question here just in the interest of time. I'm going to ask a question. What are some of the favorite brands, my cursor here, for the people who have anime as interest? I saw earlier in the marketing profile that some of the interest listed was anime. Thought that'd be interesting. Let's take a look. We're going to go ahead and generate ourselves the equivalent SQL prompt. If we scroll up far enough, we're going to be able to see the actual output as a full. Oh, there it is. Okay, here we go. Now you'll see that in fact we are going to execute a similarity search, and that is actually the operator for a nearest neighbor similarity search for Pgvector. For those of you who have used it before, we can also do cosine distance, basically whatever similarity search that Pgvector supports. So what we will need to do though is to copy this entire SQL statement, and you'll see I'm doing the top 5 documents or top 5 chunks that to be returned from the similarity search. And I'm going to ask Pgvector to do that. But remember, this is going through our proxy and taking advantage of our Real Queryable Encryption. So we could actually query and get the correct results, even though all that data, if you recall from the direct connection, was encrypted. And as you can see, we could actually get the real results. Maybe if we take a quick look, we will, in fact, I'm going to expect that we're going to see something about anime in here. Yeah, you see that? So sure enough, it's able to pull the relevant chunks for the most part, or at least what it believes is the most relevant chunks. So now what I'm going to do is actually grab this context data, copy it, I'm going to go ahead. This is the easiest way for me to copy and paste it into clipboard. And I'm going to simulate what the RAG application has to do. Right after it grabs the text chunks from a similarity search, it actually needs to feed it into a prompt that you'll send to inference server. For today, we're just going to literally use ChatGPT as our infra server / UI interface for that. And if we go over here, you see I've got a tab open. First things first, I'm going to give it usually you want to have a frame. So you might have something that looks like this inside your retrieval augmented generation question. And again, I'm going to give it the context. What should look like. Oops. Okay. So the context is and then the question is, let's go back to our question again so we make sure we copy the exact same one. So usually you wouldn't have to do this manually. This is because I just want to split up the steps so that it's actually easy for, in this particular demonstration, to see what a application is actually doing under the covers. Okay, there you go. And in fact, it is able to search through the context and give the answer. And the beauty of retrieval augmented generation is that this particular answer is very specific to context. There's no hallucinating from some public data or some other information that it may have grabbed. It'll constrain itself to just the answers in here. Just as a quick double check, you're going to see that it found some brands that's relevant. And the answer absolutely is appropriate based on what the particular context is. So yeah, I mean, that's basically it as far as this demonstration. Just to recap, Real Queryable Encryption is an incredibly powerful way to be able to operate on encrypted data. And couple that with the ability to actually encrypt and operate on vector embeddings, you can essentially now secure your vector databases and keep it fully compliant, and basically eliminate the risk of data breaches through this particular data store. Thank you for taking the time to view this demonstration. For more information about this or other Baffle data protection products, please visit our website at baffle.io. Thank you.